Good evening and welcome, everyone. I hope everyone's fine. It is fine evening. My name is Flavia. I work for Dogpatch Labs, supporter of the Dublin Data Science Meetup. We are so happy that we are having our second fully virtual meetup, and we are even happier that we're doing this with Mick, Cooney, because he is our favorite dog patcher. That's no secret. So I just need to let you guys know a few things before we start about the crowdcast. So I think you can see down here the ask a question button. So if you have any questions that you want Mick to talk about, please, you can just write it down there. There are 2 polls going on, so if you guys want to vote, that will be a great help for me and also Mick. And there's the chat box on your right. You can say anything. The speakers, in this case only Mick, the speaker is able to see whatever you guys say, so please use this space to get in touch with him. One last announcement before I pass the ball to Mick. We have our monthly event coming up, first Friday for startups from Dogpatch Labs. I'm just going to leave here in the chat box the link for registration. As usual, we always have amazing mentors, amazing lightning talks, keynote, and everything. So take your time to just read and see what we're talking about this month. It's going to happen in the 5th of June, and we couldn't be more excited. Okay, so I'm just going to pass now the ball to Mick, and I hope you guys enjoy. Thank you very much.
Hey, thanks, Flavia. Yeah, before we begin, I highly recommend First Fridays for startups. It's the talks are always really good and lots of interesting anecdotes. And even if you're not necessarily involved in a startup, there's usually several pearls of wisdom for people to learn. So thanks very much, everyone coming along, giving up your precious spare time, such as it is in this COVID-19 lockdown world. For those of you who have been here before on Dogpatch or on Dublin Data Science, it looks like it's going to be a while before the old school meetups are going to be able to be happening again, with COVID-19 being the way it is. So I was delighted when Dogpatch made their crowdcast facilities available to us so that we can start giving online talks. It also means that we can actually extend internationally as well, because I have had requests from people like in London and elsewhere saying, can you ever record? Have you ever thought about streaming your talks? So this is kind of a very natural way to do it. So because of the experimental nature, because it's the first one, excuse me, I really didn't want to convince someone to give us a talk and then have just due to the lack of us really understanding the technology. So we decided basically to do it ourselves. And hi Mihai. So what I'm going to do is this is going to be a bit different, because usually for those of you who come to our real world meetups, we tend to be quite interactive and quite talky. So I always encourage people to just shout up questions from the crowd in the middle. Just due to the nature of the tech, Flavia would have to bring people in on screen and give them access and all that. So what we're going to do is, in terms of that part of it, we're going to leave that till the very end. And once I've kind of finished the main content of the talk, we have I actually, just to try things out, I've asked a couple of our regulars to ask me questions at the end. I didn't give them pre-planned questions, so I think a few of them are planning to throw me some anchors, but we're going to see how that works. But in terms of trying to keep the interactivity on it, the chat screen is there, and we have an ask a question and the polls. So, one of the things I always like to say in my working life is that, you don't try and get the technology to adapt to the business processes. You get the processes to adapt to the technology. So that's what we're going to do here. We're not going to try and recreate Dublin Data Science live through the technology by basically giving Flavia a coronary by having her try to juggle a whole load of people coming on and coming off. Instead, what we'll do is, just in the chat there, I'm going to keep an eye on it. If people have any questions, there is an actual direct ask a question where you can kind of upvote, and it's all very web 4.0 or whatever that is. And and just general chat, I'm going to keep an eye on that. And if people have any questions, or you need me to go over anything again, or you have some specific point to make, please just put it in the chat, and we'll go from it that way. Okay, so I'm giving a kind of a different talk tonight, and I see he's here. So the title of this talk is incredibly clickbaity, and it's Reproducible Research 2.0. So I was kind of dared to call it something crap like that by Peter Brennan, who you can see in the chat. And of course, what he didn't realize is that you don't dare me to do stupid stuff, because I usually do it as long as it doesn't endanger my health or someone else's. So that's the title of the talk, but it kind of captures the idea of some stuff I've been working on lately, and, you know, some basically technologies that from the engineering / dev world that a lot of people would be considered kind of basic, you know, the price of entry in many ways, on the dev / engineering / DevOps side. But in my mind, an awful lot of people still don't really fully embrace it in the data side for various reasons, and often good ones, in that, you know, there often isn't quite a exact match between what, you know, the requirements of in the dev world and the requirements in what we do. So I'm going to talk about all of that. It's mainly going to be it's not going to be very technical in the sense of I think for the first time ever, I'm giving a code here, that a talk that doesn't have any code in it and doesn't have any graphs in it, but there is lots of images. So this is going to be a bit more high level, and what I'm trying to kind of give people some real world examples and some real world problems that I've encountered and I encounter on a fairly regular basis. Some, you know, technologies that are out there that we can adopt from the engineering side of things, and then kind of pull them across and see how best we can use them. And then at the very end, seems like we're getting a technical error. The stream wasn't able to connect. Okay. I can't help you on that one, Annie, but you might have to, you've tried to refresh a couple of times. One thing we have had issues with is using Firefox, because I use both Firefox and Chrome, and I had issues with Firefox and not with Chrome. So that might be something to mention. Okay, so yeah, so that's what I'm going to do. We're going to go on to the main talk itself now, and like I said, if anyone's got any questions or has a point to make, or whatever, I've kind of got a 2-screen setup here, so I'm keeping an eye on the chat. I'm keeping an eye on the questions, and I've also added a couple of polls here. I'm assuming most people are from Ireland, but it occurs to me that we can have a couple of people from abroad, and also just, you know, what do people use, which I think you can have multiple choice on it, mainly just to try out the technology, and we hope to kind of evolve this over the coming months, you know, until we can start meeting in person again. Oh, there is no multiple choice. Oh, okay. Sorry about that. My bad. All right, so we may as well just start. It's the best place to go. So what is reproducible research? So first of all, it's buzzword bingo to an extent. It certainly has become that. But the downside to buzzword bingo is an awful lot of things that become buzzword bingo start from a very important place, and then they get kind of adopted by a whole load of people who haven't a clue what they're talking about, and then it becomes buzzword bingo. So here's a buzzword bingo for most people. I actually had a look at this a couple of times. You're welcome to play with this bingo box if you like, but I don't know how many things I'm going to come through on that looking at. But by all means, you're welcome to play and let me know, you know, the highest number I reach. But I'm certainly not trying to use any of them. But just because it's buzzword bingo entry doesn't mean, you know, it's complete nonsense. And in fact, it's very, you know, it comes about for a reason. And one of those reasons, I'm going to give you a couple. Mainly because, for those of you who are familiar with it, the plural of anecdote is data. So, you know, if it happens once or twice, then it absolutely generalizes to every example ever. So, you know, I thought why not start with an anecdote? Because, you know, by the way, for those of you who aren't familiar, it's one of those jokes in stats that the plural of anecdote is not data. But I do find them useful. So, as you can probably tell from that, adversarial questions only. Well, yes, thanks, Duncan. Drink every time Mick says data. Yeah, that's a bit like doing the drinking game during Withnail and I probably don't recommend that, because you might die, and I refuse to take all legal responsibility. So I run meetups. Those of you who know me in person know that. I run mainly Dublin Data Science. In Shirley, you're joking, Dublin and London, and that is a regular expression in there. For those of you who, are looking at it that way. And basically, I'll talk at any meetup that will have me. I'm not proud. I'm just desperate for love and affection. So anyone who shows me any measure of kindness, I'm absurdly grateful. So I give talks a lot, and I run meetups, I run workshops. So basically, because of that, and because of the various things, I'm often giving informal help to people as well. And I'm a big nerd, so I'm usually helpful with a lot of people. The great thing I like about this Maurice Moss image is because the IT crowd isn't really on the telly anymore and it's off about 10 years, it's actually gone back into nerddom now. So whereas before it was kind of the pop culture reference of a nerd and everyone would know who this is, I gave a talk about a year ago using this photo to a bunch of kids and they hadn't a clue who I was talking about. So it just went completely over the completely went over the audience, which was great. So it's kind of like he's becoming the nerd's nerd again, which is great. So usually this is what happens. Someone comes up to me at the end and, says, I've got a problem. Usually it's not very hard. It's a simple problem that they've been kind of convinced by all this bling in the world now that we need to do something really fancy with it. When in reality, all they need to do is just load the data in correctly and then, just load it in, create some plots, calculate some means and standard deviation, do a few bits and pieces, and we'll be grand. So as a result of that, Hadley Wickham, who, it's great to be comparing myself to Hadley Wickham because, why would you not? He gave a very interesting interview a couple of years ago, and he said one of the reasons why he writes so many books and he has so much stuff out there is that when he kind of learns something new, he writes it down and he puts his code and he uses R Markdown a lot. And he kind of keeps a record of it because what happens is he forgets it. So when he tries to remember and something goes up in the back of his mind, oh yeah, I did some work on that, he can go back to all his notes and all his code and rerun it again. And that way it kind of becomes, a message for how to remember all the work you've done and creating it in a very simple way. Now, so, great stuff. Onward. Let's solve this problem. Let's get onto it. I love this image. It was pretty much this image that made me decide to go entirely image-based for this talk. And, a zebra mounting a giraffe. I mean, I don't really know. Nothing really more needs to be said about that. So, we get some stuff and let's go. Invariably, if it's something new or it's something I've talked about or whatever, I usually have something in my GitHub repo or something somewhere that I can point at. But, if you're not careful, shit's on fire is the best way. Or, to put it more politely, I don't know who that is, but I meant to look that up. I'm wondering if that's Samuel Pepys, but, the fecal matter is ablaze. So, it's fail. So we're trying to help out. Everything just kind of blows up and you're kind of dead in the water. And, your vague attempt at helping has pretty much died on the vine pretty much straight away, unless you're kind of careful in advance. So what do we do about this? How do we kind of solve these problems? Because you go back, your code doesn't work, or you can't find it, or it's buried in a whole load of things, or it was an earlier version of a code that you subsequently changed. There's there's all sorts of different things can go abroad. So, hang on, lads. I've got a great idea for those of you who have ever seen the movie The Italian Job. That's a pretty precarious position they're in. And it's probably the most famous movie cliffhanger of all time, which I found out in the end, they actually did a competition a couple of years ago to try and determine what his great idea was. And someone won a prize for it. But anyway, so, what is this great idea? So the idea is we make it reproducible. And that uses the idea from science, because the whole point of science is that science needs to be reproducible. Otherwise, it's just nonsense. And it's not science. I mean, it could be something else, but certainly in terms of learning about the world and how things work and everything, trying to figure out how things work, we need to come up with reproducible work and be able to do things over and over again. But we need to be very explicit rather than just saying, I don't want to end the talk now and say, here's a great problem. Right, I'm done. I'm, mic drop and walk out of here. A bit like the cartoon here, I think we need to be a bit more explicit in step 2. And how, what exactly do we need to do? And we also want to avoid this situation, which is, a previous project. I mean, this is funny and not funny because I worked as a contractor for a while. Those of you, I believe there's a bunch of people here who know about this. And And that was pretty much, you would get some work. It was actually split on a reasonably well agile framework, and you would get jobs to do. And basically people would say, oh yeah, that's a bit like the work that was done a year ago by such and such a person who, left 9 months ago. And it's somewhere on a shared folder on a, Active Directory, because it's a big corporate. And, we'll dig out the folder for you. And you can base your work off that. And so that is how a lot of stuff is done. And that, is if that's your way of kind of building in, excuse me, I've got repeating on myself a bit. If that's the way in which you're kind of preserving your institutional memory or preserving how things work, the fecal matter is ablaze at this point, and you're not really going to work on it well. So we need to kind of think about, how do we solve these problems? So reproducible research isn't new. It's basically how science works, and it's the whole benefit behind like publications and redoing work. And a lot of these things were done in back in the day in physics, and people would publish their experiments and other people would try and repeat their experiments and all that kind of stuff. And actually, one of the big problems we're having in science right now is that there is what's known as the replication crisis, in that just because of the way the incentives are set up now within the world, people are finding it harder and harder to replicate published research. And there isn't as much incentive to do it either. But be that as it may, there is kind of a lot of kind of procedures for doing that, and it has been done in code as well. So this is kind of a thing. You've got publication and you've got your code and data, and how does it all work? And the whole idea is that you should be able to completely, not necessarily reproduce, because there's a difference between replication and reproducing stuff, but the idea is that people should be able to take work and check the code and make sure things aren't making mistakes. A very good example of that, of which I'm just remembering now, I meant to put a list in it. I think it was Mihai who's in the chat. He sent a link to me from Imperial College London, which is the guy who did the COVID-19 analysis in the UK. And the code was an absolute mess. And I mean, it was finally put up in GitHub where people could look at it, but there was a whole load of basic mistakes. I believe there was a shuffle. There was some kind of shuffle thing that was invalid and like went out of memory, had out of memory issues, all sorts of issues, and that stuff was guiding public policy. So that's not necessarily a good thing. In fact, it's definitely not a good thing. So when people talk about reproducible research within the context of data science, they generally mean two things: that one, you should use source control, and two, you should use workbooks. And, you can then start having an argument. I believe there's still an argument today on the source control, even though most of the world uses Git these days. I do believe there's a few people that still use Mercurial. And then I think there's a couple of others out there. I think Google has its own one, Perforce or something like that. I'm sure if people know the answer, please let me know in the chat. By the way, if any questions, there is an Ask a Question, just to remind you there in the bottom left near the polls. There's an Ask a Question. You can, if you have any questions or want to put something in there, by all means, put them in. But what I'm kind of trying to say today, that would be like, if you look up reproducible research in R, you'll get books about R Markdown, and you'll get maybe some stuff on source control. And it's, in fact, mainly when they talk about reproducible research in R, certainly, and I think also in Python, they're mainly talking about R Markdown or Jupyter work notebooks and stuff like that. But what I would argue is that to get proper reproducibility, you need more than that. And we need two more things. One of them is we need make files. So we need to manage our dependencies, because, quite often we're going to have a lot of, moving parts where you've got, and I'll talk about this a little bit later in the talk. But also we need containers in Docker, and we need to start wrapping our code into small, lightweight containers that kind of capture the version control. And basically, I'm going to go through the problems, and I'm going to discuss why we need each of them. And that's kind of the basis of the talk, is going to be covering these four topics, a bunch of links at the end. And, we'll see how it, yeah, I haven't looked at, I don't use Jupyter at all. I'm going to talk about that a little bit in section 2, why I prefer R Markdown. But we can talk about that afterwards. Yes, it was Neil. He had, no, it was more than hundreds. I think there was thousands of lines of C. It was C and C++. Was how most of it was written, and it was all like, I looked at it. Mihai shared it a couple of weeks ago in one of the Slack channels, and when you look at it, it's like thousands of lines of code with no functions or anything. It's an absolute mess. Probably started to see it. Usually does. So like you can see, I'm keeping an eye on the chat. So okay, so the very first thing that most people kind of talk about, but some of them don't. Have I got anything else? No, I don't. Source control. So if you take one takeaway from tonight, use source control. Start learning it. I know it's a bit of a pain, but you will save so much time using version control. And I know for the more dev-focused people here, this is probably just preaching to the choir, and you're probably surprised that I'm even saying this. To them, it's probably like reminding people to breathe, or don't go out and kill people. But I have found that the adoption of source control, certainly in the data and research and like statistical modeling world, is nowhere near as high as it needs to be. It basically needs to be basically your starting point, and everything goes into that, and that's how you start your work. In the same way that it's happened in software engineering over the last 10 to 15 years. You had excuses in the past because some of it was pretty janky and it didn't really work very well. Source control just works now. But I mean, we still see things like this. This is I just looked up this, but also, this is quite a funny one with the final docs and the final revs. And just to show that this actually happens, the coronavirus file name was found somehow online. And that's the file name that was released to the public. I particularly like the HMG in the middle, which I presume means Her Majesty's Government, and recovery. So obviously Word crashed on someone. So that's just a great one. That to me, if you ever have files like that or worse folders like that, you really need to start adopting source control and just use Git. Because like I said, once again, the fecal matter is ablaze. Git is brilliant. I mean, I'm just going to tell people to use Git if you don't use anything else. If you use something else, that's fine too. I know some people really like Mercurial. They're pretty interoperable in many cases. It allows you to track the changes. It allows you to collaborate with people. The big thing is things like, you're doing some work and you want to make a couple of changes. You can just create new branches and make those couple of tweaks and then merge it back in if it works, or just throw it away if it doesn't. It's incredibly important in this kind of stuff to actually track what you're doing, and also managing, tweaks to your model or different versions of the same model. And you can just handle all that very, very simply these days in Git. You only need to learn about 7 or 8 commands to be, 80% functional with it. And then every so often a couple of things break. And also just, unless it's internal, put your stuff up on GitHub. Just make it up there. It becomes your CV, if nothing else. That's what I tell people. Ask me about careers or wanting to get started. So I just tell them, do something that you find interesting, find a data set, analyze it, and throw it up on GitHub. And then you can point at it to people. This is what I've done. GitHub gives you a bunch of nice other bits and pieces. It helps you manage your issues. It helps you do branch management. There's a whole bunch of extra features that are helpful, but not necessarily killer, but very, very handy to have. And it means your stuff is abroad and you're not checking everything to git add Duncan. Yeah. I'm not sure what that is, but I'm pretty sure it's bad. Yeah. Anyway. So so just I use it as a matter of course. In fact, before I start a brand new project, the first thing I do before I do anything else is I create a brand new repo in GitHub, which is why you will probably see there's a whole load of public repos up there that are completely and utterly empty or have very few things in them, and I've never really gotten back to. At some point, I'll either get back to it if I have loads of time on my hands, or more likely it will either get deleted or it will die with me when my account gets deleted after I'm in the grave. But it's very handy for that. We use it for collaboration and work all the time. I mean, well, we've all done that. One day I spent a day having locked myself out of sudo on a website that had just gone live and I needed to reboot. That was not fun. I ended up, in a data center at 2:00 in the morning as a single user in single user mode. That was not fun. Okay, so just use Git. I've provided a bunch of links at the end. If it's integrated very well into things like RStudio, and I'm not sure if it's in Jupyter, if it's actually integrated, but it probably is. One of the reasons I don't really like, well, I can talk to that afterwards about that. Excuse me. And so that's the main takeaway. If you don't really give a hootenanny about anything else I say tonight, just use GitHub and Git, and it will make your life so much easier. and you can now start messing around and doing new things with confidence because you've got a version checked in that works, and as long as you don't break everything too badly, you can always revert to that version of the code and get things working again. Okay, so workbooks. So workbooks are kind of, like I said, the kind of what people mean when they talk about reproducible research. So the question is, what is research? So like in data science, there's all sorts of different things, and people talk about machine learning engineers and what's the difference between a data engineer and a data scientist and all this kind of stuff. And in a lot of cases, it's all just nonsense. It really just depends on what people are calling things. But to my mind, almost unless you're doing like hardcore production stuff, in a lot of cases, you're working where your outcome is unknown. You don't really know what you're doing. You're being handed, a big wab of data or a username and password access to a database, and your brief is find out stuff. And that happens a lot more than you'd think. Quite often, most people don't know what they know. They don't know what they would like to have, and you end up just having to do stuff and seeing what happens. So you've no idea what the work will do, and it might only take 2 or 3 days where all you really do is pull things down, you segment it by a bunch of categorical variables, and you calculate some summary statistics, and that might be all people want, and that might be all you need. But inevitably what you're going to do is you're going to try lots of stuff, and almost everything I'm going to Frascati research document defines different types of research: basic, applied, incremental, and industrial improvement. Sorry, Peter, is that a third? Is that incremental and industrial improvement are 3 and 4, or is incremental industrial improvement a third one? Do you know? 3 types, yeah. I mean that to me makes sense. I mean, you've basic research where you're just learning stuff for the sake of it. So that's like in our world, it will be coming up with a new predictive algorithm, like from scratch. Applied is where we're taking a whole bunch of things and we're applying it. So, for example, using survival analysis in churn modeling for your customer service stuff and your customer relationship management. And then obviously incremental industrial improvement. We have our churn model, and now we need to make it a bit better, or get it faster, or get it working more predictive on a certain cohort of that it doesn't really work on right now. All that kind of stuff. Yeah, that definitely makes sense. But I mean, the key thing to all of this is that we don't really know what the outcome is. We don't even know what the outcome looks like. We've got to try a lot of things. The problem is you end up with Bacon Studio. So very quickly, you're trying. You've got a bunch of scripts over here that pull stuff down from your database, and you're reading in a CSV file, and you fit a model with this one, and you want to keep it a bit clean, so you're creating another script and all of that. And the point I'm trying to make is, once again, the fecal matter is ablaze. So even though you're using GitHub and you're using Git, I'm using my source control, I'm keeping a track of everything, but even though I'm being diligent about making commits, I'm going to come back in a month's time and everything is going to be a complete and utter mess. And, I'm using scripts here. I'm doing stuff like that. So, I mean, what did scientists do in the past? So that there is a notebook of Isaac Newton from back in the day. I'm not sure which one it was, but I do know his notebooks went up for auction a couple of years ago at Sotheby's, I think it was. And it was done by some collector who was like an amateur physicist. And he was very disappointed when he discovered that what he bought was mainly stuff on alchemy, because what people don't really know about Isaac Newton is, as well as running the mint and coming up, inventing gravity and calculus, he was also a huge alchemist, because back then alchemy and physics and all this kind of natural sciences, there was no real distinction between them. So to him, he didn't really, and most people at the time didn't really see a difference. So he spent a crap load of time working on alchemy, and that's what this guy bought. That was what he got in his notebooks. This is another one I found, so in lab notebooks, and this was something I learned when I was in college, is, when you're doing experiments and you're doing stuff, you just keep notes of everything, of both good and bad. So your failed experiments, you measure things down, you take a note of everything. You have to be very careful on it. I remember being graded on my notebooks, on literally the handwritten notes. Now, and then obviously later off, you would create a report and type it all up. But you actually needed to keep a track of that, because in many ways, your negative results are as important as your positive results, because you need to make sure if you've made a mistake, you want to track that mistake so you don't end up repeating it 6 months later when you come back. So that is how, to me, as a record of work, you need to treat your workbooks. So like, and the great thing about workbooks is with R Markdown and Jupyter and all these, they allow you to kind of blend your documentation and your code and your outputs, like your graphs and your tables and all that, into a single place. And that then becomes your record of work. So as you're doing stuff, you don't kind of have to throw stuff away and delete a bunch of files. You just kind of create a brand new workbook when you're starting something new. Now, it becomes a bit of a mess and you need to kind of, keep a bit of a track of it. But again, like I said, we're using Git, and we can always track, so we can go back in time if we need to. But, you can just keep things away and, create a brand new workbook, get things started. And the great thing about this is, as long as you're a bit neat and tidy and, you're diligent about your notes, when you come back to yourself, the joke I always say is you're always working for at least two people, yourself and future yourself. So, make sure that current you is nice to future you and doesn't become future you's mortal enemy. One thing that I really liked and what really hammered home the point for me is I work in insurance, which is a notoriously kind of tech-free zone. For those of you who know me in real life will, hear me rant about it on a regular basis. I see Michael and Jerry are in here, my colleagues, and Duncan. It's an absolute nightmare. It's worse than a lot of people. I know there's a few people here from the banks. It's way worse than the banks. And I got a job about 2 years ago working on a property book, commercial property, natural catastrophe exposed in the US. And, they knew that it was on fire. The fecal matter was ablaze there from a business point of view. And they needed to do some work on it. So I did a bunch of work. I created a bunch of markdown documents, and I came about it. And then about 6 months later, a guy came up to me. I was back within the company doing some work on another project. And when he heard my name, he said, "Are you Mick Cooney?" I went, "Yeah." And I went, "Oh." And he kind of came up to me and went, "Oh, this can't be good." But he said, you did the work on the DNF. That's what they call it, direct and facultative. I says, "Yeah." He says, "Wow, that was really good. I kind of got handed that and I thought it was a hospital pass. But because you laid it out with notebooks and, with documentation and stuff, I could actually follow it and it all kind of made sense." And I was like, "Yeah, that's pretty much what reproducible research is all about." You look at the stuff, you can run the code, it's all there for you, and it all kind of works, and it's happening. So there's a bunch of different options. Jupyter is very, very popular in both Julia and Python. A lot of people use Jupyter, and there's Jupyter Hub, I believe, as well, which is a way of kind of version controlling it. I've heard of Apache Zeppelin. I know Peter, who's here in the crowd, he uses Apache Zeppelin quite a bit, and that's kind of it's an Apache project that's very cross-platform. And the idea is that you can tie in to a whole lot of different things. So, for example, you can write a code block which is SQL based that produces a table that you can then is automatically available as like a table variable as a pandas data frame in a Python block or as a data frame in R, and that kind of stuff. It allows you to kind of do a lot of that stuff. So if you're dealing with a lot of kind of disparate data sources, Zeppelin notebooks can be very good for that. My preference is R Markdown. I use R all the time. I don't really use Julia or Python much. And when I use SQL, I tend to use SQL, just pull the queries down. But the main reason why I like it, and it's possible Zeppelin and Jupyter have this ability now, but one of the reasons why I didn't like, it took me a while to warm to workbooks, was they're not very amenable to source control. So because they mix the input and the output into a single file, it's much harder to kind of manage properly within Git, and the files get very big. And also for me, because I was working in consultancy, because there's technically customer data in the output. If you have a plot or the output of a table, it's essentially a data breach if I was to then push it up to GitHub. So what I like about R Markdown is, a bit like the LaTeX days, there's an input file and an output file, and you kind of have a separation between the two. So it kind of, it works kind of nice that way. If you use Jupyter or Zeppelin or anything like that, I highly recommend you strip all the output before you're making your commits. That used to be a bit messy. You used to have to write Git hooks to do that, to make sure that you didn't accidentally commit, live versions. So what I like to do is I like to have an input file and an output file, which is what R Markdown gives me. But if anyone knows if that's changed within Jupyter and Zeppelin and the various other notebooks, please let me know, because to me, that would be quite important. But anyway, yeah. So, and most people do that. So, that's kind of the way it's in. But the key thing is, and this is where people go, notebooks are not for production. Notebooks are for science. So notebooks are a track of your work. At some point, you're going to stop and you're going to either write some production level code that's written as a script So if it's in R, Python, whatever, you're not writing it as an IPython notebook. You're just writing a script file, and probably you have to do a bunch of other things like, error management and a whole load of other things, to do it. I mean, sometimes you can, and in theory, you could use your notebooks for production, but it's not advised because it's not, it's inappropriate use of the tool. You can get away with it, and I've done it in the past, and I'm doing it at the moment, where basically that is my production pipeline, mainly because it's a manual process right now, and I haven't automated it, but it's certainly not a long-term fix to the things. This is very much for what am I trying to do? How am I trying to convey some ideas? And how can I mix all my work together so that when I go back in 6 months' time, or if I'm handing over to someone else, or if we're kind of documenting a lot of things in a lot of places, that's what I want my notebooks to be done for. Okay, so that's kind of where most people think, and we're kind of done. Yeah, I mean, Peter's just said there for ETL, it's not bad. I mean, that's true. The problem, yeah, it's a bit tricky. It is handy from that point of view. I think what I'd almost want to do is both, though. I'm not sure I trust it for production just because of, you're having to. I guess you could strip out all the code, and that the code then becomes your script, and you could do it that way, I guess. But yeah, I mean, I take your point on that. That it is very good to remember, especially if you've got weird pipelines. Now, I have heard there are a bunch of things like Airflow and stuff like that are meant to be very good for that. I haven't had a chance to look at them yet. I'm not quite sure how that works. But now we're going on to kind of the stuff that I think is where reproducible research is going. So to go back to the point we had before, I mean, if you look at, this is my car insurance. I've talked about before. I've given talks on it. If you notice here, I have a bunch of R Markdown documents. And I'm going back to my old school 10, 20, 30, 40 days, which was, for those of you who ever programmed in BASIC, it was how you organize your code. You would put line numbers in. So that was kind of the way I used to do this. That's not very good, because what happens if all of a sudden something appears in the middle? You end up with line 25 or having to renumber them all. It doesn't really work very well. This is basically a directed acyclic graph of the dependency, part of the dependency structure in a program I'm working on at the moment. So you can see there is a bit of a workflow from top to bottom between the data generation and all that, going down. Well, that's just a dummy variable that I've produced, but managing all those dependencies, and also let's say, for example, if I'm building my frequency models in this HTML file, if I change this, I don't want to go back and have to, rerun all these codes and regenerate all these unless I have to. So in the dev world, we end up with Bacon Studio once again, and yet again, the fecal matter is ablaze. So how are we going to manage that? I don't like the line numbers. It's bad. And also it suggests a very linear progression, which is not always the case. And it's just messy. There needs to be a better way of doing it. And there is. With dependency management, there's make and makefiles. Now, again, this is a very, very standard tool. Make was written in the 70s as part of the Unix system. And it basically does dependency management. So it treats everything as a directed acyclic graph, like I mentioned before, which is very common nowadays. It's kind of become the common thing. Git, for example, is a directed acyclic graph, and it allows you to basically do very clever things in terms of the management. And code to a separate, and then Git ignore the notebooks. Yeah, I mean, the problem with that though is you could write the code, but then if you can't save the notebooks, then you're also losing all the code and you're losing all the text and the output. You're kind of. I see what you're saying in terms of creating a script, but it's not the same. And that's what we used to do as well. But it kind of becomes hard to reproduce it then, because all you end up with is a sequence of Python code, and maybe your text is in as commented out, but it's just messy. It's much better if I could just have an input file and an output file and strip all the outputs. I know there is a way of doing that in Python, but having to do it as a hook is a bit kind of tricky. But yeah, thanks for that. So, and just to mention about directed acyclic graphs, this is SecDB, which is securities database, which is a piece of technology invented by Goldman Sachs for their trading, their proprietary trading. So they invented it in the mid 90s, and their big problem was what they wanted to do is they kind of think about their I'm talking about finance here, so a lot of people consider it evil, but it's actually a very interesting topic. One of their issues were they thought about things from a firm-wide point of view. So what they didn't want to do is basically what happened to the world in 2008. They were trying to avoid the situation where they ended up with a whole load of correlations in their risk that they were unaware of as a result of separate, trading operations, trading things that had some kind of just one sec. The door here is open. I'll be back in one sec. Sorry about that. The door's closed now. So they wanted to make sure that if they did a trade, they wanted to sign kind of how it fit into their global risk position. The problem was they would have, thousands, and at the time, I think even in the 90s, they would have tens of hundreds of thousands of positions across all sorts of different asset classes. And doing that calculation was incredibly difficult. But what they wanted to know, if they changed something, they only wanted to recalculate those parts of the system that were affected by that change in positions. So they came up with securities database. They've now actually they sell access to it as part of their prime brokerage business. But that all uses logic from a directed acyclic graph. By the way, incidentally, for those of you on the stats side that like probabilistic graphical models, a Bayesian network is a directed acyclic graph as well, which is why it's relatively fast to generate quickly, because with a directed acyclic graph, you can really reduce. There's none of these circular dependencies that cause problems. The other great thing about makefiles is you can put sysadmin tasks in them. So I just realized I actually should have put some code in here, but I have some afterwards. And I meant to do that and I forgot. But the idea is you kind of specify your dependencies like in this graph, and it's all in a text. So you have like here, for example, this directed graph came from my makefile. So there's a couple of pieces of code out there that allow you to turn your makefile into a graph, and then that way you can visualize your dependencies. So that's what you do. You basically say, rather than have 10, 20, 30, I'm basically saying, okay, well, construct company census data. This file here depends on the input file. So the output file depends on the input file, but it also depends on, process data sets. And construct the statistical models data set depends on both construct company census data and calculate share price data, and so on down, right? So you kind of end up building your structure. And what it does then is, so if I change something, it only checks what needs to be done, and it only rebuilds those parts of the graph that need to be rebuilt. So say, for example, I make an edit here to this RMD file, and I want to, convert export data sets into the HTML file. It knows this doesn't need to be rebuilt. None of these up here need to be rebuilt, but this one does. So it rebuilds this, but this one actually is an input to this one. So it'll rebuild this one as well. And then it redoes this one. So the render process will end up just rendering 3 notebooks instead of all of them, right? And it saves your time. But also you can build in like sysadmin tasks. So what I've done is, for example, there's a bunch of, rather than creating a whole load of bash scripts and shell scripts and everything becoming messy, I can put all these targets into my single makefile. And this is a trick I learned from Duncan, who's in the chat. You kind of wrap all that code that you needed to remember before. And I would be searching through my bash history. You just put it in as a target in your makefile, and that way you can remember it, and you have it all there, and you have a whole sequence of targets. So you kind of can use make as for your sysadmin tasks for copying files. So if there's a particular, if you needed to do an rsync or some kind of copying or going to a URL and downloading a file, you can actually put that into your makefile and download it, and you can make the target to be part of, so say, for example, all of this depends on going online, downloading a CSV file from a particular data set, and then running processing scripts on it. I can actually build my target so that it will do that, and it will check to see if that file is there. And if it isn't, it will run that other one to pull it down before it starts to run all my code. So it basically saves you a whole lot of time and a whole lot of effort. And it means that you can then start to go back to my earlier point. You can have lots of different notebooks, and it doesn't become nearly as messy, because in the make file, you've got all your dependencies explicitly written, and then there's a couple of tasks. I mean, if you want to visualize it like you have there, which is something I've started to do recently, you can actually generate that image, and there's a couple of online scripts off Git and whatever that will let you do that. So yeah, so I mean, I think make files are becoming, and it's something I learned ages ago because it was originally done for C programming when you were compiling code, because compiling executable binaries just became this mess of a whole load of .c files and all that kind of stuff. It kind of solves all that problem, and it just kind of takes it all away. And now we can adopt that to modern uses. It doesn't just have to be for compiling C code. Okay, and there is a bunch of other dependency management and like codes, and there's Ant and there's Chef, and there's a whole bunch of like dependency management stuff that works. The great thing about Make is it's ubiquitous. Almost every system has some version of Make, even Windows has one, and it's kind of become it's got some weird stuff though, like it has tabs versus spaces, the whole Silicon Valley joke. That's a very, very real thing in Make. It's basically widely acknowledged to being the single biggest UI or like user experience mistake in the history of computer science. So you have to have the commands have to be preceded with a tab. They can't be preceded by spaces. And it was just kind of something he did really quickly, he said. And kind of by the end of the first week or two, he wrote it really quickly one summer because people were giving out, and it was a bunch of colleagues. And he thought, oh, this quick fix, did it up. And then everyone started using it really quickly. So I think within a couple of weeks, he said he was going to change it, and then he realized it was going to piss off 12 people. So he left it, and the rest is history. Okay, so and I have, again, like all these, I have some links on Makefile. So finally, we're going to talk about containers and Docker. Now, this is containerization. And containers is a big thing in like dev management and engineering, and it's something I've been talking about learning for a long, long time. But to explain why I think it's become much more important, we're just going to go right back to the start of the talk. So if you can remember, this imaginary person has came up to me, asking me for help with something. It's triggered a memory. Onward Noble Steed. I've decided, yeah, absolutely. I've worked on this before. I know exactly what needs to be done. I can kind of show you the points I'm talking about. We go to GitHub. I pull the code down. I've, version controlled it up the wazoo. I've got my make files built. Everything's all good. And I get this. And this is an actual error. And this error here is what prompted me to start using Docker about 3 months ago. And this is exactly the problem that happened to me. I was working on something new. I had a bunch of code, and I was trying to remember what I had done in the past, to go back to the Hadley Wickham reference. I pulled down the most recent version of the code, and this was back in the day when I used data table a lot, and basically it broke on me, and I got this exact error. So once again, the fecal matter was ablaze. Crap. What am I going to do now? So you have a couple of options. I mean, the obvious one was to go back and like fix my code, but that wasn't particularly useful because there was quite a few things to change, and I'm the kind of person. Did I put a tab on it? No. What had happened was the packages had changed. It was literally the packages have updated, and my old code broke. There was breaking changes. So I wasn't really sure what to do, because I knew if I went back and tried to fix that piece of code, I'd end up breaking all, and I'd have to fix it all, and it would just become this thing. And what I really wanted to do was, this was supposed to be a 5-minute fix of going back, reminding myself of the code I had done in the past, and kind of copying that and reusing that to kind of steer where I was going in the future. So I thought, well, I know this worked like 2 years ago because I used it for something and I didn't get this error. So I thought, I'm going to have to rewind my code. And this is where Docker comes in. So this is pretty much the problem that Docker is designed to hold. So you've got code that if you're using certain libraries, the libraries change, or the underlying operating system updates, so suddenly a bunch of stuff doesn't work anymore. That whole dependency management on an industrial scale becomes an issue. And the whole idea with Docker is you create these kind of lightweight container machines, and you can kind of snapshot them in time and say, well, I know this works, so as long as I have this container, this code will always work within this container. And it's kind of an encapsulation around this. And why I think this is becoming very important is because this is also going to become important in regulated entities in particular. I know there's a couple of people here who are working in insurance. One of the things they're talking about is pricing. So like on the consumer side, making sure that the public are being treated fairly in terms of their car insurance quotes or their house insurance quotes or whatever it may be. One of the things they're starting to look at now is the use of machine learning and predictive models and all these kind of advanced tools. And you're going to need to be able to reproduce all your pricing models and all your mechanisms. And that's all very well and good, but you also need to be able to do it in 18 months' time when there's a complaint and you have to wind the clock back 18 months to prove that you haven't done that. This is kind of the way regulators seem to be going, certainly in insurance, but I think more so in pharma and healthcare and the legal, there's a whole bunch of areas wherever they're using kind of machine learning and statistics in heavily regulated industries. I think you're going to start to see the regulators go this route where it's not just going to be about having copies of your code. You're going to have to hand them systems that directly reproduce your code from possibly 2, 3, 4 years ago. I think Ben is still here. I'm not quite sure how far back the regulator can go, but it can be a good bit. And I know there's things like IFRS 17 in and IFRS 9, which are kind of starting to impose these kind of restrictions on financial services. So, I mean, we need to use containers for this, because what you need to say is, okay, well, this code was written for, say, again, I'm using R, but it's similar in Python. Let's say it was R 3.4.6. So I'm going to have a container that has that version of R with all the, the versions of the libraries from 2 years ago or from a year and a half ago, whatever it is, and rebuilding them. So that's basically what I did. There is a thing in R called in Docker and Docker Hub. There is actually a guys called Rocker, which is reproducible build to fix versions of R. So there's a bunch of guys. It's the guys who do RCPP, Dirk Edebrettel and those guys. They have a whole bunch of containers for R, and they even snapshot CRAN for your packages. I'm sorry, the Julian Python people, any year into that kind of stuff, I don't know how it works on their side. Although considering how they tend to be much more dev people than stats people, I imagine it's even better on the Python side. But they basically, you can go back in time and they've actually snapshotted the packages. So like the CRAN version is a time-stamped CRAN version on a certain day. So even if you accidentally do update packages, you don't nerf your machine, because it will only go up to whatever day that was. And that kind of sets the CRAN setting. Now it's not entirely perfect. There's a whole bunch of extra builds. So there's an RStudio version of it and Verse that also includes LaTeX. They have a whole bunch of extra stuff. They've actually just released in the last 2 or 3 weeks, the Rocker guys have updated for use on GPUs and all that kind of stuff. It's really, really good. It makes all that stuff very, very simple. And I highly recommend, if anyone's starting to look at Docker and doesn't really know how, Rocker is really good. It's pretty well documented as well. And, by all means, if any of this stuff you want to go, that's basically the way to do it. Now, it's not perfect. There's always issues. There's a bunch of weird permission stuff with Docker that you just have to be careful of. It's also not perfect there's a couple of things you need to think about in this. And this was one of my reluctances. My biggest problem with this is Docker is kind of designed to be self-contained. So the idea is, your files get copied into the container. So with Miniconda and Anaconda, okay, cool. My problem though is, what I'd like to be able to do is, I don't want to, because I use Git and GitHub, and this is how they all interact. I want to work inside my container from the get-go, so that I don't have to worry about putting a container around it later. I like to just spin up my container and not really have to worry about it anymore. And I can work from inside my container, because I can just spin up the Docker container, RStudio is installed as RStudio server. So it mounts on 8787 like it does for a lot of people who have used RStudio server. So I can just connect into the IP address of the container or even localhost and then go localhost colon 8787 and work away. But the problem is that what I'd like to be able to do is work on the file system outside of the container. So you can handle that as well. You can mount volumes within Docker, and that took a bit of hassle. So I kind of have my code. I check out my code on the host machine. I create the container within that, but I can map my working directory in as a volume inside the Docker container. And if you look in my make files for a bunch of these, you can see how to do that. It's relatively straightforward. The other big benefit of Docker as well is that it means you can actually use Unix within Windows pretty easily, because you can just create a Unix container with inside Windows. Now, sometimes mounting the volumes and stuff can be a little bit tricky, but putting all that out, getting it there, and it means basically, and just to go where I did, I looked at my code and I looked in GitHub in terms of the dates, and I figured out what date did this work because I had commits around then. And I just went back onto the rocker and I roll back the versions. And it goes back to about 2015, I think. I can't remember exactly how far it goes back. And I just pulled up one of those versions of R, and it was a timestamp CRAN, and everything. I kind of spun up the container and ran my code, and I didn't get the error anymore. And suddenly, it kind of worked. And that was the point that kind of completely convinced me that I now need to start using Docker as a matter of course, because when I and you build them through Docker files, so it's just a text file. I put it into the same directory along with my make file. I have my make commands that build the image and start the image. You can do your Docker compose, which is a bit fancier, where you've got multiple Docker machines running if you need a database, say, for example. But all this technology is here, and it's actually much easier to use than you would think. And while it sounds like it's a bit of overhead, first of all, like as a data science people, we use computers as a matter of course, so we need to know how they work. It's not good enough to just kind of, the computer says no, and RStudio doesn't work and close it again. Like, we need to understand the operating systems and how this work. I know it's a lot of knowledge to know, but first of all, there's a lot of competition coming out because all the cool kids want to do data science stuff, and not all of them are learning how to use computers properly. And secondly, it actually saves you time in the long run, because sometimes these things are actually simple fixes, and it's just a matter, the more you do it, the easier you get to it. It's actually much easier to learn the basics of how to use a computer than it is to learn statistics, for example. So for anyone who's kind of started on the stats road, you're already miles ahead in terms of cognitive difficulty, in terms of learning the basics here. Okay, so there's a number of issues. This is one that happened to me. Sometimes APIs break. Not all APIs necessarily are as good about versioning as they should be. So I had this issue. Yahoo Finance are notorious for it. I download share prices from that, and when the APIs change, it doesn't matter that your Docker container worked 2 years ago, because it's querying against an external API that doesn't support what you're trying to do anymore. So it's not a gotcha. It's not a complete panacea, but it does solve an awful lot of problems. Okay, so start to do it. So in summary, we talked about 4 things in terms of reproducible research, like source control, workbooks, make files, and containers in Docker. So for those of you who have looked at, I actually, after I discovered Docker, I went back and I put Docker containers into most of my talks. So all the talks that have, the R markdown and the data and all that in there as part of my GitHub repo, there's now a make file and a Docker file, and the make file contains a bunch of abilities to build and run the Docker containers that the code sits inside. And I've included all the commands to the Docker run. So all the volume mounting and all that, that's all kind of handled there. So it's also kind of documenting this reproducible process. Talking about it is one thing. I wanted to provide some aspects of it, but so these are kind of a couple of very good links. This is a weird link here because Joel on Software, Joel Spolsky, I think he still has his company Fogbugs. He built a lot of stuff on Mercurial, and he had a brilliant introduction to source control in very kind of graphical methods, explaining how things work and how they do, called HG Init, which went down about 1.5 years ago or 2 years ago, but it's been saved on the web archive. In fact, looking at that, I think it was September 2018. I presume that's a timestamp. Oh shit Git is great because that kind of solves the problem of just because Git is a bit arcane in terms of its language because it was never really designed. It wasn't conceived by Linus Torvalds to be used the way it was. So it was all very much a geek's geek. So some of the words are a bit weird, and some of the, when you're coming in learning Git, you've got to learn kind of these kind of sub commands that are a bit weird. So oh shit Git in play index says, this is my problem. How do I solve it? So it's a very good starting point. It's Git the simple guide. Thank you, Michael. So that's oh shit Git, and then the standard book from the Git SCM, which stands for Source Control Management. There's a book online built by Claude Chacon, I think his name is, and that's a very good intro to Git to help you get used to it, or to start using it. And GitHub is very easy to use as well. It's publicly available. You can also create private repos now. They changed the business plan a while ago, so it's free to create your own private repos. You just can't share other people with them. There's limits on how private repos work, but for your own personal work, it's no problem at all. On the workbook side, I kind of did a bit of, so most of this was a bit of Googling over the last few days. I tried to find one for Jupyter, Zeppelin, and R Markdown. If any of you have any better, please put them in the links and do all of that. On the make files, we're going to, sorry, I've been asked to think, Flavia, I think Michael has a question, Michael Crawford. So would you start bringing him up, please? We're going to test out the brand new tech, but Flavia asked for a bit of notice because it takes a little while to get the permissions organized and all that kind of stuff. So just to let you know, Flavia, if you're here. So on the workbook side, we have Jupyter notebooks, we have Zeppelin and R Markdown. There's a couple of nice links there. We have the make files. So these are basic introduction to make. There's some stuff from Docker. And I kind of came across a couple of them. Maybe I'll talk about them in a bit because I see we have Michael on. Hi, Michael.
Hi, Mick. This is just, I don't really have a question as such, because more of an observation. One of the things that you were talking about was the work you did in the insurance company. And what struck me from knowing those guys, the one thing they did, they came back after about 4 or 5 months. And they said, it was really interesting, the stuff that you did for us. It was great. We got the technical work done. He said, but the most valuable thing we learned from you was working this way. It actually changed the way we actually work with data, because before, when we were going back to look at things, we'd have to start from scratch. It was always a fight. And now we realize if we did things in this kind of reproducible way, going back and actually reproducing work or starting again and doing it again or building on it was just, was basically simple. And that was an incredibly encouraging thing to learn, because when we started talking to those people at the start of that project and asking them to do things like use source code control or use Markdown, they fought it tooth and nail. They thought it was a complete waste of time. Why are you wasting my time? My time is valuable. And then they realized in 5 or 6 months' time, actually, because we've done this now takes half a day instead of 6 weeks.
Yeah.
And that was incredibly valuable. So this isn't just academic, it's just, it really, really works.
Yeah. I mean, one guy in particular, he kind of knew he had to do this. He just didn't want to. But I think even he couldn't really argue with it after a while, because it just made life so much easier when you go back to it, because you forget a whole load of stuff after a few months. Jesus, I forget a couple of things after a week or two. You go on holiday and you come back and it's like, what the hell did I do here? But yeah, absolutely. I mean, it's in many cases, it's not so much what you do, it's how you do it. That's the most important. Thanks for that. Flavia, would you bring up Paddy? I think Paddy has a question as well. But yes, while we're waiting on that, we have, I'll talk about these extras here. So software carpentry is kind of based on that idea of, as I said, behind a lot of these things are based on, hey, Paddy, just give me 1 second. Actually, no, go on, we have you on.
Okay, well, it was just one question, as you were talking there, finding that I myself will take a section of code and then put it elsewhere. So as you were talking about your Markdown, I have this bit where I solved a problem and I was like, okay, I'll move it over here. What would you recommend a way to trace that?
Ooh, that's a good question. To trace that. So are these on completely separate projects?
These be on completely separate projects. So you've walked through, goes, I've sort of found a cool way of doing something and it's in this R Markdown. I'm going to take it out and move it over.
The obvious answer to that is if it's generalizable, generalize it and put it into a package.
Yeah.
And turn it into a library. And that way you can, and now you do have a slight issue in that in a lot of cases that code will be, kind of specific to what you're trying to do. So it might take a certain amount of work to try and abstract it a bit so that, you can kind of customize the columns or the variable names or whatever, but wrapping things into a function and then creating your own like little utility library. I mean, you can put it up. I mean, there is a bunch of libraries on CRAN. Like HMISC is the classical one. It's Frank Harrell who wrote regression modeling strategies. HMISC, as far as I'm aware, is just his personal package that he has a whole bunch of, because there's a whole bunch of stuff up there. Like one section is entirely on generating LaTeX, which has been kind of made redundant these days because of our markdown and all that kind of stuff. But, that was kind of, so that's probably the first thing I would look to do. If it's more general, where it's not, it's more of a concept, that's what I think I would probably do there is I would try maybe just create a standalone a standalone project that just does that piece of work that you can then refer to it. So you don't necessarily copy the code, but at least you then you've kind of documented that process. And then you have that to refer to then. So at least you know where to look in the future. Which is why I did my car insurance one. I mean, the car insurance process came about because I was working in insurance and I didn't know how to price it. And I'd heard about GLMs and I'd only ever used linear models. And I wanted to learn, how does this all, I kind of knew it in theory, but I needed to do it in practice. And as a result, it's kind of become, I mean, to the point where it's so old now and so crap, it's in bad need of an updating. And as soon as I get like a free couple of weeks, that's basically going to be my project where I do that up because I've learned an awful lot about simulation and modeling. So yeah, I would just do that. I would create it as like a little standalone thing. And that way you have a reference to it. And you can put a link in it. I mean, if you make it public, like I said, I mean, that's the kind of thing I would put on a public GitHub where you can just say, and that way you can start to point to it. But you can always put the URL reference, we're proceeding this a la this link here, which is the GitHub reference, which is what I do like with data specs. I always provide a link to data specs at the top of the template so that you can link back to it. And that's kind of how I would treat it.
Yeah. I can see and obviously if I had that code age, Docker would be the solution.
Yeah. I mean, yeah. That, I mean, just wrap it in a Docker container.
Yeah.
That's actually very easy. That's much easier to do than I expected to. Even going back into, I thought it would be a bit like trying to put the toothpaste back into the tube, as Michael says. But it was actually quite easy. I just had to they actually have timestamps on all of them, so you can just go back and say, oh well, what was the version on June 2018?
Yeah.
And you base your Docker file off that version, and then it builds, and it generally works. Assuming it worked back then, it should work now.
What was the learning curve for Docker?
Not too bad, actually. A lot better. Myself and Peter kind of started around the same time. Peter's on deck, by the way, Flavia, just so you know. It didn't take that long. It took the two of us maybe a week to kind of pick it up. We knew a bit of sysadmin though, but it's actually not very hard at all. And it's very easy because you can build a container off one of the existing ones off Docker Hub and just get started. But then later on, you're going to want to run Docker files so that you can pre-install all your libraries. But in theory, you can just build a Docker container, run it, and then do install packages inside the container. It's just the problem is if you kill the container and have to create it again, you have to reinstall all your libraries again. So the Docker file kind of avoids all of that. Cool.
Cheers.
Thanks, Paddy. Cheers. Peter, I think, was next. And if anyone else is, sorry, we've got a couple of questions here while Flavia is bringing people up. Just let's have a quick scooch. So let's see. Oops. Who is the most to gain from reproducible research? Are there any downsides? Is this the hospital pass you were promising me, Duncan? I'll have to think about that one. I can hear him laughing already in Wicklow. And then finally, in a production environment, what are you putting into a container? The model scored and data. Oh, thank you, Fiona. I'll get to that in a sec. That's two great questions. Who is the most to gain? That's easy. You do. You have the most to gain, like the person doing the work, because whatever about everyone else, and it's nice to help other people, but ultimately it's a selfish thing that motivates a lot of this, because when you do your work and you're trying to build your research out, you don't want to fire and forget, because an awful lot of work is very similar over and over again. So you want to be able to kind of do the same things and have reference works it also encourages you to kind of do a good job because you know you're going to be using it later on. So it's a bit like, you know, when you write code for yourself, you try and write it with a certain amount of coding standards just to be nice to yourself. What about other people? Are we waiting on Peter? Are we, Flavia, is there? I just don't want to get.
Hi, Mick.
Hi, Flavia.
I don't think Peter got the invitation. I'm just gonna ask Duncan. He's also.
Yes. Yeah. No problem.
All right.
So just to answer the question that was put in there, I think that's the person who is the most to gain is you. I mean, you're the only real person you're going to gain. Sorry, was that the question you were going to ask, Duncan?
No, I was more kind of going back to lamenting the you managed to stop saying data, so we're all parched here now all around the country. So we could see you going and sipping away while we're getting thirsty here. So much for our drinking bingo game. Kind of what I was getting at really was there any particular things that were hard to reproduce? So like, I'm thinking of kind of environment or importing drives. Were there any particular things that you found that were difficult to reproduce?
We've had trouble with, I've struggled in general with things like Amazon S3 buckets and Google Cloud Storage because just there's fiddly permissions, getting that to work. So mounting it within the container can be a bit tricky, and certainly mounting them doesn't work. We were kind of forced to use, the Google Cloud storage packages that are in R, where you've got an authentication file. So those can be kind of tricky to use. But I found that with Amazon S3 as well. The other thing that was a bit tricky was the cross-platform. Was that mounting volumes within the Docker file, which is kind of the way I work. So I kind of work on my host machine. I have a container running, and I kind of do a pass-through volume, so I can do all my Git and all my kind of source and like file system stuff in the host, but run things within the container. So that generally works okay in Ubuntu, and I imagine it works fine in Macs, even though I don't have one. Windows can be a bit tricky just because it is a bit different. Now, things like the use of PowerShell and stuff like that have made that easier, but that can still be a bit tricky to get that right. I solved that problem by trying not to work in Windows whenever possible. But, that's not always an option for people. So that can be a bit tricky.
I mean, the other thing there is obviously by gaining the other thing that we're all gaining by putting stuff in Docker files, etc., is that we're able to run it in the cloud. So that bit of pushing it up and not having RM minus RF trash your entire thing, or obviously the command was a bad one. Add everything and then drop it straight away. So all of these accidents happen to everybody. Yeah. So what can we do to prevent the downside a little bit?
Yeah, the brilliant thing I found now with using Docker, especially, that has really kind of sold me is that, I tend to use a lot of cloud machines anyway now, because I just find I end up killing my laptop doing, running processors or whatever. So rather than having to spin up virtual machines and do all the install and all that crap, basically I just create Docker containers. So now when I spin up a brand new virtual machine, I'm just doing Docker pull and Git pull and whatever, building my machines on my building my Docker containers on my virtual machines, and everything just kind of works now. And I don't really have, and even if it does take a little while to build the Docker file, if I don't want to pull it down, it's not fiddly at all. It's all kind of scripted within the Docker file, and it just works. It's brilliant.
The interesting thing was they recently released the code live spaces where you're actually editing on GitHub, and it's integrated into the editor, etc. So all of that is essentially packaged for you.
Yeah.
So the VS Code live spaces, so like that kind of stuff basically. And as part of that, you can actually build in, here's the Docker file to set up the environment, etc. that I want.
Yeah.
So that's a game changer for a lot of people.
Now, and the other great thing is, now there is, like I said, Docker is probably the one that's the most mismatched. Like, there's absolutely no excuse not to use version control in data science. There's absolutely none. there's no real excuse to not use workbooks for, you know, the outcome unknown stuff where you need to document what you're doing and plot stuff and all that kind of stuff. If you're working in production, it's different. But for what I'm calling like the research work, because it is reproducible research, it's not just reproducible work. You know, when you get into make files, I can see the argument there, you know, if you've only got one RMD file. But to me, I mean, Docker is the one that doesn't quite match, because to get to, I'll let you go off, Duncan, but thank you. Fiona, just ping in the chat. I'm going to ask you a question. Do you want to jump on, or are you happy enough? We're coming slowly to an end now. Invite her on anyway, Flavia, Fiona McGroarty, the woman who asked the question. But I'll address your question. I'll start with it anyway. Is that in a production environment, what are you putting into the container? The original model development, the model scored on the data. So you're basically putting, now again, I am not, you probably know a lot more about production than I do. But what I would put is the trained model that's going to run. Hey, how you doing?
Hey, how are you?
Hey, good. How are things? Good to see you. So so I mean, it's a little bit tricky, like I said, and to go, because there's a bit of a mismatch between, when you're in a production environment, it's very much dev work. So it's like, you know, you're in a production environment, you're basically doing any other piece of software production code. You're very much in a dev environment then. So all I would put into the container is like the trained model, or the code that I need to use to produce the output from a production point of view. So you don't really need you don't even need like your things like your cross-validation model or any of that other stuff. All you need is your trained model, unless automated cross-validation is part of the production process, in which case you try and keep it as minimal as possible. So you try and keep your containers small and lightweight, but all that other stuff can kind of sit out in your Git repo or whatever, where you have all your everything documented that produced the fitted model. But I would only put whatever I need as part of the production process into the production container.
Okay, no, and it is a fair point, because, you know, your development model you have anyway. The only thing that's going to change really is going to be your data over time.
Yeah.
And then I guess if you have data that's periodic, you kept a record of the data over time, chances are you could just rerun it now. It'll be close enough, but not exactly identical. So it kind of depends on, you know, where the regulation is going. It could be that the one customer that you're particularly interested in is the one whose data wasn't exactly
it's
identical.
for that kind of stuff where your data set is going to grow with time. I would always put a timestamp on it, so that I can filter out all that data and essentially version my data. Even if I'm doing it back in time, I would always look to version my data as much as possible, so that I can track those changes over time. Now, whether or not you'd put that into a container or not, that's a bit of an ecumenical matter. You know, that is kind of, it really depends on what you want your production process to do. In most cases, I'd say you don't really care so much about training the model. Like if there's an automated, if you've set your model up in such a way that it's automatically training itself and all that, then possibly. But in a lot of cases, that opens up a whole new can of worms, because you've got to make sure it doesn't train badly. And you've got to monitor the whole training process and all that. So in a lot of cases, you could probably get around with like just doing a manual run, making sure everything's fine, and then pushing up the newly trained model. And that's what goes into your container.
Okay. Yeah. No, that's a good point there. Cheers. Thanks.
Cool. Thank you very much, Fiona. Okay, I think, does anyone else have any questions? We have those two. Well, thanks everyone for coming. I don't know how many people we actually got in the end. I know there was a whole bunch of people registered. I'm not sure how many people we actually got live. I'm sure Flavia will be able to tell us. But we're kind of starting to wrap up now. I'm going to hand you back to Flavia in a minute. I have a whole bunch of stuff in there on the extras page. Sorry, I didn't quite get to it. You all know my email and address at this point. I'm going to share the slides online, as always. I always do. So there's a whole load of links on there. If anyone has any questions or whatever, you all know how to find me. Oh yeah, sorry. Fiona asked me to mention there is a job going for a senior data scientist. So she asked me to mention it. Thank you for reminding me. If anyone has any interest, just ping her directly. I said I would do that as a favor. Yes, that's kind of it for this month. We're hoping to basically do this now on a monthly basis. Next month we'll have Richie. I think I'm not exactly sure what he's going to talk. He told me today and I've forgotten. So the other co-organizer, Dublin Data Science, is going to do the June talk. We don't exactly have a date yet because Flavia, I need to speak with you and Jenny and Ashleen tomorrow about getting it in the calendar. Ideally, it'll be on a Wednesday because one thing I've discovered, I only discovered this morning, is that one of the big R organizations runs weekly talks for an hour at 7 o'clock. And you know, some of us would like to see that. So I don't really want to clash with that because I want to watch it myself, or at least be able to. So instead, what we'll probably try and do is maybe run it on a Wednesday from now on from 7 to 8. We're also probably going to start up our workshops again. Maybe in June, maybe July. We'll see how it goes. I'm probably going to run them on Zoom though, because I expect that to be much smaller, and that will be kind of using our Markdown and just going through much more technical stuff. And yeah, we're going to try and have this once a month online because I really like Crowdcast. One of the reasons we didn't do it is for larger things like this. A lot of the software out there isn't great, like Google Meet and Zoom and stuff. It's just a bit janky. Whereas this is a really, really good setup, and they use it a lot for their First Fridays and stuff. So I'd like to thank Dogpatch and all of you for showing up. I really appreciate it, and we hope to see you all next month. And Flavia, I will hand it back to you because I think you have a couple of words to say.
Yes, thank you so much, Mick. Guys, I just want to say thank you very much for being here. And I just left here in the chat box our social media, LinkedIn and Twitter. So it's great if you guys could check it out for next events. And I'm also going to leave my email in case any of you is looking for a host or is planning a meetup but can find a really good platform. So I'm just going to leave it there. I'll be really happy to hear from you guys. Okay, thank you very much. I hope you guys enjoyed and see you next time. Bye-bye.